So this is a demo of our application, which focuses on scheduling satellite activities. As you can see here in our assets page, we have a map of all the satellites in our constellation, as well as all the ground stations. And as you can see, the satellite's location updates in real time, and the map is interactive. We can see the status of each of our assets here. At the moment, this is not completely connected to the backend, so the data here might not be correct, but this is a minor fix. If we go to the health dashboard, we're able to see an overview of the system. For example, in this area, we can see it shows us out of the past 100 orders, what percentage of orders have we successfully scheduled. So it gives us a snapshot of our system. We see we've successfully scheduled 97% of orders, and we can see the current spare capacity and storage of the satellites, as well as a chart here which shows how events are distributed amongst our different assets, amongst our different satellites. So we can see here that our scheduler, in this case, has very evenly distributed scheduled events to satellites in a very evenly distributed way. And here we can see system alerts. Whenever an event happens, we get an alert. We are able to create maintenance orders, image orders, as well as outage orders. Satellite operators are most interested in maintenance orders, performing scheduling activities such as memory scrubs or some other routine activity on the satellites. Meanwhile, some third party may be more interested in image orders. Operators will most likely be the ones who perform an outage, who schedule an outage for a system, and third parties are not concerned with this. So we are able to create a maintenance order, select the target satellites, and what describe the activity, provide the window of time within which it should be scheduled, as well as how many times this order should repeat. So when we actually go to the schedule request window, given that each order can repeat, the schedule request window shows each request, each instance of an order. So as you can, and it also shows its status. As you can see here, we have a number of schedule requests that have already been scheduled. We have some that were rejected. And our algorithm is actually able to provide a reason for the decisions it makes. Whether it schedules an item, it provides a reason why the procedure it went through. As you can see here, this that was scheduled was first displaced due to an outage, and then it found a new spot and was scheduled. We see this one here that was rejected. It was rejected because there was no available time slots to schedule this event. The same is true for image orders. We have the order view here, as well as the schedule request view that shows the individual instance. If we look here, we're able to select, actually, if we go to, let's review all requests. If we go here, the operators are able to select requests and decline them. If, for example, they have some event that was scheduled that they no longer want to occur, they can decline these requests, and it's removed from the system. And as you can see as well, the details of all the scheduler's decision, the algorithm's decisions, are stored and are retrievable. We are also able to have a view of all the events that have been scheduled in our system. First, we have the table view, but more importantly, we have the timeline view, which gives a more convenient view of our system and all the scheduled events. As you can see here, each event type is color-coded. Maintenance events are purple, imaging events are orange, and we have other events here that we can see as well. We see the outages. We can also view contact events. So this is when a satellite is in contact with a ground station. And when we hover over them, we're able to see details about them. So in this contact event, the satellite 3 is in contact with the Gatineau station. And these events are computed lazily. So if we do not need to know the contact periods given a period of time window, we don't compute that. So that allows the system to be more efficient and responsive. And yeah, as you can see, when we have an outage, no activity is scheduled during the outage. So in this Gatineau station here, we see an outage. No contact event is used to actually perform a transmission through this ground station. And we see more visually here that when this satellite is in outage, there are no orders that have been placed, that can be placed to this satellite during the outage period. And we can actually demonstrate that. So say we want to make the satellite for an outage for a good while. So let's say we want to make it an outage starting from 7 a.m. Monday, 2nd October, and say let it last a month so that we can see how, just to test the edges of the scheduler's performance. So Monday, 2nd October from 7 a.m. We create an outage order on satellite 4, I believe it was. Monday, 2nd October from 7 a.m. And let's go to, say, the 31st of October. So when we make this, if we're quick here, because the scheduler is pretty quick, we can see the scheduler in action. These imaging events have been displayed, but if we go back, it's looking for new places to schedule these events. So it should have scheduled, it's processing some of these, and it finds a new spot to schedule these events if we just wait a little. So we can go back here and see that from the outage we've created, all the events that were scheduled there have been kicked off and are now looking for new spots to be scheduled. Let's see if it's made any progress. Yeah, it's scheduled one of that. This one, it's displaced, is still in the queue to be scheduled. It's still, see, it's processing some other requests. If we look here, yeah, it's processing one of these requests. And when these are rejected, we actually see the reason for rejection. As we see here, this was one of the ones that was just displaced. It was displaced due to an outage at satellite with ID 4, and it was rejected because of that. Some of them were displaced, but then they found a new spot and were now rescheduled. And that pretty much gives we also have the system time here. We're able to set the current system time. Basically, this is what is right now with reference to our system. And so our scheduler actually takes this into account. If a user puts in an order for the past in reference to our current time, system time, then that order is rejected. If we set, for example, the reference time to be 1st September, when we go to the timeline view, it actually starts us off at our reference time. If we set it back to be in October, it starts us off there so that we have an easy view of what's going on currently in our system, in the current system's current reference time. And of course, we're able to add new assets, new satellites, new ground stations. The satellites, you just have to provide a TLE file that describes the path of the satellites, and that is all you need. And I believe that gives an overview of the working of our system.